are moving on to sectors. And your learning target today, you can calculate perimeter and area of various sectors, but area is tomorrow's learning target. Today we're fixated on calculating perimeter of sectors. So a sector is a part of a circle, also known as section of a circle. So I have these three circles here for you to draw yourself a visual on what a sector is. You could have this little sector. See that little one? Notice I put the angle measure. That tells my eyes, hey, you're looking at the line that's connecting that angle. What you also need to know is arc length. That's a vocab word I keep forgetting to put into this lesson, but arc length is a huge vocab word you're going to use today. And arc length is really, watch this, part of circumference. So, a sector is part of a whole circle, and an arc length is part of the circumference. Think about, look at, here's an arc. See, part of the circle, each time you section off a circle, there's going to be an arc that's above it. So this is an arc, and then the length means how far does that arc go, okay? So this little section here is really the arc length. And what we're going to be able to do today is calculate arc length and then find the perimeter of a sector. And let's give ourselves some more visuals. This one, notice that always on the sides of sectors, it's connected together by radiuses. So a sector, if I were to pull a sector out, let me just do that quick. So there's my sector. If I were to pull it out, it's really two radiuses, isn't it? So what if I were to pull that sector out, and if I were to say, hey, what's the perimeter of this thing? Well, the perimeter would be your radius plus part of your circumference. Part of your circumference is that arc length, okay? So, there you go. And then another one, you can also have super big. Sometimes people think that arc lengths are always the smaller measure, but you could have an arc length that's bigger than 180 degrees. And that's a-okay. What you have to do, wherever your radius is, you have to follow the pattern of that central angle, and your arc length goes to the other radius. So if I were to find the perimeter of this sector or section, it would be radius plus part of the circumference plus the radius, right? And that would give me the whole perimeter. Look, it looks like Pac-Man. Very messy. Okay? So that brings us to our actual learning target. Now you have some visuals. I've shown you what an arc length really is, and that it's combined together with a radius. Perimeter, what you want to do, it's the sum of the sides around the shape. So perimeter is sum of the sides around the shape. Nothing new is the formula is different, because when we're talking about part of any kind of circle, you're dealing with pi. And so it's going to get slightly messy or look super smart like. All right, let's talk about this sector. So I'm talking about the smaller one. And I want to know, what is the perimeter of the sector? Well, what you want to find out is the arc length. You need to figure out what in the heck that arc length is. And I don't think I have an angle measure here, so I think my goal was to just show you what the formula really is for this, because I don't have anything I need. I can't calculate this. I don't know the angle measure. But it would be R plus R, right? When you find perimeter, you would do this plus the other R plus part of the circumference. That part is really the arc length, circumference. I need more room. R r plus part of the circumference. How do you figure out part of the circumference? That's the biggie, and that's when you actually need a proportion for that. So to figure out part of your circumference, to figure out that arc length, also known as arc length, to figure that out, what you need to do is create a lovely proportion. So to create a proportion, we're really going with this part is to whole as part is to whole. It's stemming from Unit 6 when we started getting introduced to proportions, except we have to go slightly deeper. The circumference is that part. Part of your circumference is to your whole circumference. Your whole circumference is pi times diameter. That's where that's stemming from. Part of the circumference, which is that arc length, is to the whole circumference, pi times diameter, as part of your circle degrees, also known as your central angle, is to all of your circle degree, 360. Part is to whole as part is to whole. That's where that's coming from. Okay? Part to whole. So, again, part of the circumference is to the whole circumference, as part of the angle is to all of the angles. All right, scoot that over to the next page. Okay, steps for finding the perimeter of a sector. The first thing you're going to want to do is identify the central angle. Because we need that central angle. We sure do need that central angle because that's how we do step 2 when we create a proportion. And then what you do is add around. So maybe give yourself a visual of what a sector is. Just make a little sector. And when I say add around, that means you go r, radius, plus r, another radius, plus this part of the circumference, which is also known as the arc length. They're synonyms. It really doesn't matter which word you use. Okay, so let's apply this. Let's find the perimeter of this first given sector. So the first thing it says I need to do is identify my central angle. What is the central angle of this sector right here, Kens? 1/4. 1/4, which is how many degrees? 90 degrees. So this is a 90-degree central angle. Okay. Then, what I need to do is create a proportion. That's step 2. Step 1, find my central angle. Step 2, create a proportion. So the reason why I'm creating a proportion, my purpose here is I'm figuring out my arc length. I'm figuring out what the heck is this dimension. That's what I'm figuring out. And to figure that out, you have to do part is to whole as part is to whole. So when I create that proportion, the template of the proportion, maybe you want to show that up here. Your template is always part of your circumference is to pi d, as your central angle is to 360 degrees. Part is to whole as part is to whole. So, part of my circumference, whoopsie, I'm going to erase that. Part of my circumference, or my arc length, is to my whole circumference. Well, my whole circumference is pi d. Well, I have a radius of 4, so my diameter is 8. Do you agree? Yep. Because all the way across would be 8. So my whole circumference is 8 pi. So you can write 8 pi here. Part of my circumference is to my whole circumference as part of my degrees, 90, is to my whole degrees, 360. Use 3.14 for pi, and then you just start plugging into your calculator. So I'll go 90 times 8 times 3.14. Remember, you multiply the diagonal numbers and divide by the number that's left over. Divided by 360 is 6.28. That is not my whole perimeter. That is my arc length. So that tells me that that 6.28 is what this section is. So my perimeter is my arc length, 6.28, but I have to add around the shape plus my radius of 4 plus my other radius of 4. It's hard to see that 4. And that gives me a total perimeter of 14.28, and that would be whatever units that is. That would be a singular unit. It's not square. Square is tomorrow with area. So, holy moly, that's a lot of mathematics. Again, my strategy. Figure out my central angle. That's the first thing I did. I figured out my central angle. Second thing I did, create a proportion. That proportion tells me the arc length. The third thing I did is found the actual area, which is arc length plus radius, right? That's how you find perimeter. All right, let's find the perimeter of a sector that covers 2/3 of a circle and has a diameter of 14. So step 1, I need my central angle. So I have to do a little bit of work for my central angle, because I'm not given a visual and I'm given 2/3. So really what I want to do is break my circle into thirds, right? Because 360 is divisible by 3. So if I do 360 divided by 3, that means each third is 120 degrees. 1/3 is 120 degrees. I have 2/3. So I have to have another 120 degrees. For a grand total of 240 degrees is my central angle. If you like a visual, if you look to be like where'd those numbers come from, I figured out what 1/3 of it is, and then I doubled it because I wanted 2/3. Okay. So that was my step 1. Now I can do step 2. I'm going to give myself a little visual because I feel like I like to see what perimeter really means. So you can just draw a random circle and try to draw 2/3. And clearly this is not to scale. There's 2/3 of a sector. My diameter is 14. So what is my radius then? So that means that I have 2 radiuses of 7. And now I can create my proportion. Part of my circumference, that's this. That's what I'm figuring out here. Part of that is to the whole circumference, pi times diameter, 14 pi. As part of my degrees, 240, is to all of my degrees, 360. Then I multiply and divide to solve this proportion. 240 times 14 times 3.14 divided by 360 is 29.3. X equals 29.3. Now keep your eye on the prize here. I only figured out arc length. 29.3 is on the outside. So the third thing you have to do is find the actual perimeter. So my perimeter is, yes, that 29.3. Whoops, that's really bad and off scale. But that's not around the shape. I have to go around the shape. So it's 29.3 plus my radius, 7, plus my other radius, 7.